Now, let's move on to next problem. The problem is over chemical kinetics and it describes us the effect of temperature over the rate of reaction. It involves the application of Arrhenius equation. Let me read the problem statement and let's gather the data. The rate of reaction doubles when temperature changes from 300 Kelvin to 310 Kelvin. Initially, temperature T1, which is 300 Kelvin, and final temperature T2, it's a 310 Kelvin. When temperature change from 300 to 310 Kelvin, rate of reaction get doubled. Means the final rate, let us write R2 upon initial rate, let us write R1, and R2 upon R1 is 2. And rate of reaction is directly proportional to rate law constant. We can also say the rate would get doubled because rate law constant would get doubled. R2 by R1 is 2, means K2 by K1 is also equal to 2. Now, we are asked activation energy for the reaction. We are supplied with universal gas constant and the value of log 2. We directly need to apply Arrhenius equation. We know log of K2 by K1 is equal to EA upon 2.303 R into 1 by T1 minus 1 by T2. This equation describes the variation in rate of reaction or variation in the rate law constant with temperature. We directly need to apply this. Log of K2 by K1 is given to us. Log of K2 by K1 is 2 is equal to, we are asked activation energy 2.303. For R, we will substitute the value of universal gas constant which is provided to us. For T1, it's 300 minus 1 by T2. We'll substitute the values. Now, in order to solve for activation energy, the value of log 2 is provided to us, 0.301 into 2.303 into 8.314 into 300 into 310 whole upon 10. We can always write expression for A in this manner. Now the problem involves the calculation part. We need to calculate it accurately. .3 into 2.3 can be written as 7 and 310 can be approximated nearly equal to 300. On solving this equation, you should get 53.6 kilojoules per mole. Hence, this is the correct answer to the problem. Activation energy of the given situation for the reaction is 53.6 kilojoules per mole. Let's move on to next problem.